So in this video, we're going to learn how to solve quadratic trigonometric equations requiring the use of the trigonometric identity sin squared x plus cos squared x equals 1. Now, this identity we would have learned last year in National 5 when we were looking at trig equations. Now, we can see obviously that the equation itself involves sin x and cos x, or sin squared x and cos squared x, and I suppose we can make other equations out of that. So if we just start here with the original equation, sin squared x plus cos squared x equals 1. If we want to make sin squared x the subject of the formula, then we can subtract the cos squared x from both sides, which leaves us with sin squared x equals 1 minus cos squared x. That would then allow us to use 1 minus cos squared x as a substitution for sin squared x, if that had to come up in an equation where it wasn't the most useful situation and we needed a cos x in there, then it would maybe be better replaced with this. Now we'll do the same so that we've got cos squared x, the subject of the formula this time. So we can subtract sin squared x from both sides here, and that gives us cos squared x equals 1 minus sin squared x. So again, we might be able to use that later on. So let's look at an example. We'll just look at the one example here. So we want to solve 5 cos squared x minus 2 cos x equals sin squared x, 3 sin squared x, for x lying between 0 and 360 degrees. Now, firstly, on my left-hand side of my equation, I'm noticing that I've got two terms which involve the cosine function, and on the right-hand side, I am noticing that I've got a term involving the sine function. Now, it would be really useful if at this point I had either all cos x's or all sine x's. Obviously I don't. Now the sort of outlier here, if you like, is the sin squared x. So I'm going to replace that. And if you remember from the previous slide, I showed you this. So we rearranged this trigonometric identity to get sin squared x equals 1 minus cos squared x. So if I substitute that 1 minus cos squared x for my sin squared x, that might actually help me within this equation. So on the right hand side, that then gives me 3 bracket 1 minus cos squared x, which if I expand that bracket I get 3 minus 3 cos squared x. Now if I rearrange this equation, I can add my 3 cos squared x to both sides and subtract my 3, and that will get me 8 cos squared x minus 2 cos x minus 3. And I have a quadratic equation here. So in order to solve this, you'll realise from the last lesson that we need to factorise this. So factorising will give me 4 cos x minus 3 multiplied by 2 cos x plus 1 equals 0. So for the first expression here, we've got the null factor theorem here, so these brackets can equal 0, so 4 cos x minus 3 equals 0, and 2 cos x plus 1 equals 0. Now solving the first equation gets us cos x equals 3/4, if I add my 3 to both sides and then divide throughout by 4. And then the second equation, if I subtract my 1 from both sides and then divide throughout by 2, I get cos x equals negative 1/2. Now I now need to solve for x. So I've got these two answers for cos x, and again I'll take them separately, get a cast diagram for each of them. So the first one, I know that cos x is equal to a positive number, and that means that the answers occur in the first and the fourth quadrants. So inverse cos of 3/4 is 41.4 degrees, and in the first quadrant my answer is 41.4, in the fourth quadrant my answer is 318.6. Now, I also had cos x equals -1/2. I know because this is equal to a negative that my answers occur in the second and third quadrants. So inverse cos of +1/2, remember that's an exact value, alarm bells should be going off in your head just now, so that is 60 degrees. So in the second quadrant my answer is 120 degrees, and in the third quadrant 240 degrees. So I've got 4 answers here. So x is equal to 41.4, 120, 240 and 318.6. Now, if I just have a wee quick look at the graph of the original equation, so 5 cos squared x minus 2 cos x equals 3 sin squared x. Now, it's quite an interesting graph, or at least I think so anyway. So the green curve that you can see, that is the graph of y equals 3 sin squared x, so that's the right hand side of the equation. And the red curve, that is the graph of 5 cos squared x minus 2 cos x. And our answers are the points of intersection here. So you can see that there are 4 points of intersection, and one of them, the first one, is roughly halfway between 0 and 90, so that's the 41.4. You can see the 120 here, so that is a third of the way between 90 and 180. 240 is here, and then we've got 318.6. So those are our 4 answers. So again folks, copy this down in your notes jotter and then try the assigned exercise for today.